major impediment to successful enterprise AI. Many use cases there do require subject matter experts for labeling, for example, for building models for conversational systems. And the screenshot on the right-hand side shows you a use case in which users had to label utterances, selecting from multiple labels on the right. SMEs are very expensive and they have very little time, so it's an interesting area where AI assistants could make a difference. So we tested this hypothesis with 54 users in a between subjects experiment in which we administered assistance through weak AI, so trained on less examples in this case, versus strong AI, trained on more examples. So this sort of was a label recommend assistant. And just looking at the AI alone without human involvement, so we get 44% or 59% accuracy respectively. However, when combining human with AI assistance, we can achieve up to 79% accuracy, which is a great example how the combination of human plus AI is better than either side alone. So let me conclude this part of the talk by giving you one last example outside data science automation where we are augmenting human capabilities through AI. Recent industry successes in robotic process automation, you have heard the term RPA before, have moved the area of business process management into the focus of AI. So here are actually tremendous opportunities for AI automation. For example, in a recent side-by-side comparison, we tested our own AI ops tool. This is an AI-powered process automation tool that helps with IT incident management. The tool applies machine learning and AI techniques to massive amounts of log files. And in this comparative study, we were able to show that incidents can be resolved significantly faster with less steps, requiring less people at a fraction of the cost. So if you're interested in learning more about AI Ops as a tool and product, I've left a reference below to a keynote Rama Akiraju gave at BPM 2020. Now you can imagine that a system like AI Ops consists of many components that solve different problems. So we've been thinking about how can we actually generalize the use of AI for business process automation, making it more domain independent, and also making it available to non-subject matter experts. In some of our case studies with customers, we identified also natural language interfaces as something that would lower the barrier of entry for non-subject matter experts. So in order to generalize AI-infused process automation to more domains, we've started exploring more flexible systems that support the composition of process automation applications based on multiple agents and natural language integrations. In these multi-agent assistants, we envision human and digital workers to collaborate to accomplish a task. And at the heart of this idea is an intelligent orchestration layer depicted here on the right-hand side that decides which agent to invoke at which step in the process. To the end user, for example, a loan officer, as illustrated in that chat transcript on the top right, this orchestration is typically invisible. In the short example above, the PDF document is processed by a content analysis agent, whereas the loan decision is managed by an agent that is able to make rule-based decisions for loans given the right parameters. So if you're interested to learn more about this, I've included a reference below of a BPM 2020 paper that describes this use case in more detail. But you can imagine, given the conversational interface, that this system also provides an excellent playground for us to experiment with human AI collaboration. So with this, Casey, now back to you with more on human AI collaboration.
Thanks, Werner. As we give this talk, have you noticed the interplay between Werner and I? We are collaborating to accomplish a shared goal, giving this talk. And to do so, we have patterns of communication, for example, turn-taking. We have behaviors that we exhibit. We say thank you. How humans and humans communicate with each other has been studied for years by anthropologists, sociologists, psychologists. And HCI is the study of human-computer interaction. applying the same rigor to understand how humans interact with computers, or in the case of computer-mediated communication, how a computer between two humans interacts. We hope to apply the same lessons and theories as we advance into computer-AI interaction. We want to study the nuances between the sides and how they communicate, collaborate. What we are doing is we are applying the same theories and conceptual models that we learned from these prior fields to inform the new studies. We'll present our conceptual models for making sense of this space and present a number of research findings related to social perception, mental models, cognitive bias, and explainability. So as we build up our conceptual model of human-AI collaboration, let's start with the AI on one side and the human on the other. Now, we know these are obviously different, but in some ways, they can be thought of as acting similarly. Our study with mechanical Turkers tell us that AI can be thought of as being modeled on human intelligence. And again, at a very high level, they're doing a very similar sub-processes. For example, each side is gathering knowledge, managing and storing it about the world. While we might use words on the AI side, like vectors or data mining or embeddings, and on the other human side, we might use words like chunking or visual learning or information foraging, reading. Each side is ultimately gathering and storing this data. At the next level, each side is trying to make sense of this at a higher level of abstraction. Reason about the incoming data, store and augment additional metadata on top of that. The notion of sense-making was introduced in psychology in the 1970s by Carl Weick. It was brought into HCI domain by Park researchers in 1993. And words on the human side would probably be familiar to you. Things like perception or mental models, interpretability, even concept mapping. If you think about it, on the AI side, there are similar things going on. For example, topic modeling or clustering can be thought of as making sense of the underlying data at a higher level of abstraction. Next, each side is participating in decision making. At this conference, I'm sure there'll be a lot of talk this week about things on the AI side, like predictions or classifications or regressions and decisions. It's happening on the human side too. For example, there we might use words like preferences or goals or intuition or habits, but it's all part of decision making. Uniting these concepts together was first done by Chun-Wei Chu, a faculty member at the University of Toronto in 1998. At the time, it was being used to describe an organization as a system. But I think we can also use it for our purposes and understanding how each side is operating and the internals of the conceptual models of each of those as we think about the broader perspective in human AI communication. So now that we've thought about how each side is operating, what about the collaboration between them? To help us understand and reason about this, we look to the Shannon-Weaver model of communication developed in the 1940s. In that model, there's the notion of an information source, a channel over which information is delivered, and then an information receiver. Looking at that from our perspective, we can think about the human and the AI having a channel between them. That channel can mean many different things. It can mediate the information being sent over it. It could take the form of a conversational interface, like a chat between an agent and a human. It could also take the form of a graphical, web-based interface or tool for data scientists, as in the case of the middle screen you see there and what we heard about earlier from Werner. Or it could even be games, which might constrain and mediate the channel and how the two sides are allowed to collaborate even more. But we haven't yet talked about directionality. And I told you that the Shannon-Weaver model assumed that there was an information source and a recipient. So let's add into our model the ability for either side to initiate the communication. If we look at it from the AI side, the AI can encode information about its internal state. It can then pass that on to the channel between the two parties. And then you can think about the human side then needing to decode the information coming from that channel and needing to then use its internal processes like knowledge creation and sense making and decision making. Let's look at a very concrete example now using our conceptual model. Let's go back to the visualization we heard about from Werner earlier. If we think about this, again, how the AI first now needs to encode information about its internal state, things like how many models there are and the accuracy of each model. Next, it needs to then encode that information and pass it on to the channel. The channel can dictate what the form of the information is. For example, if you have a text-based interface, you probably can include a graphical visualization on it. The way the encoding would probably be done differently if that was the case. Then think about once a human is now looking at the visualization on the channel. They need to decode the information there. They need to make sense of the lines you see in the chart and then process that and think about how that relates to ultimately their view of how the models are working to make a decision about which model to select. On the other side, you could think about the human initiating. Very similarly, here the human is encoding information about internal state, similarly posting it to the channel between the two, and then the AI needs to decode and make sense of that information. And with bidirectionality of communication represented, our conceptual model of human-AI collaboration is complete. Now let's use that conceptual model to organize and help explain some of the recent research findings from across our team. We are not going to spend a lot of time focusing on the left-hand side, how the AI gathers and creates knowledge, does sense-making or decision-making, even though our team actively researches in those areas. We think you're going to get enough of that this week at the conference. Instead, we're going to be focusing on the right-hand side, how humans can participate in sense-making during this collaboration. In particular, we're going to share research results related to social perception and mental models. We're also going to talk about how cognitive biases can affect human decision-making as part of the collaboration between human and AI. And finally, we're going to present results related to explainability, or the communication between either side. So first, let's start with sense-making. Again, sense-making is how the human processes or reasons on top of the underlying knowledge that was gathered and stored. We did most of our sense-making research within the context of an online word guessing game, which you see on the right. This guessing game is a two-player cooperative game, with each player playing a different role. The giver role knows a secret target word and will give the guesser clues or hints in order to help them guess the secret target word correctly within 10 tries. Within the context of this game, we studied social perception, which is how you perceive of your collaboration partner. We know from prior research on human-human collaboration that how you perceive the person on the other side affects the collaboration itself. So we wanted to understand, how do you perceive your partner when your partner in collaboration is AI? To study this, we set up an experiment where participants played the game. Some were told they were playing with an AI agent, some were told they were playing with another human player, and some they were told they were playing with either. In reality, all participants were playing with an AI agent. We surveyed the participants in each of the conditions to understand how they rated their partners on a number of subjective social perception dimensions, such as creativity, intelligence, likability, whether you felt like you had rapport with your partner. Can anyone guess the results? Well, if you guessed that when people believed they were playing with another human, they found their partners to be more likable, more creative, more intelligent, and having greater rapport, then you were right. We also gave participants in all conditions the ability to use open-ended results open-ended feedback to describe their partners, and we found that people who believed they were playing with another human use more positive sentiment words to describe their partners as well. So now we know that when we enter into this communication between humans and AI, we're already facing a little bit of a negative social perception. In a follow-up study to this research, we went back to try to understand how variations of the AI can affect how people socially perceive their partners. So we varied the kind of models that were used in creating the AI agent. Humans weren't told this, but we did measure the social perception differences. We also varied the model who initiated the communication. If you remember that in this game, there are two different roles. The human or the AI could assume either role. What we did is we found that in particular, when the AI was the initiator of the communication, or they were playing in the giver role, giving their human partner clues, the humans were socially perceiving them more negatively. So now you understand how you can vary things within your AI systems to affect how people positively or negatively perceive the AI. But I'd like to leave you with one last thought about social perception and human AI collaboration. What we found is that even though players perceived their partners more negatively when they thought they were playing with AI than other humans, it actually did not statistically affect the success outcomes of the game, winning or losing. That's different than prior findings on human-human interaction and how social perception of your partner affects success outcomes in those collaborations. Next, let's move on to mental models. If social perception is about how you rate your partner on subjective dimensions like creativity, your mental model is how you believe your partner will think and act. In human AI collaboration, we believe the aspects of a mental model include how you think the AI behaves in a local or global way. An example of local or global might be how the AI agent will respond in the next turn for this particular target game versus how it will act across targets or rounds played in succession. Also, we believe it matters how the human reasons about how the AI was trained on data and its knowledge distribution. In this series of experiments, we showed that playing the game more didn't necessarily increase the accuracy of your mental model about how the AI partner works. However, we did show that people who have more accurate mental models about the partner and how the AI works did have more successful game outcomes. A natural follow-on to this, of course, would be, so how can we change people's mental models to make them more accurate? Well, in follow-up research, we tested interventions that would improve a user's mental model across these various dimensions that we discussed. Our findings show that fine-grained influence over particular aspects of a mental model is possible. These particular interventions were around describing how parts of the AI worked. But our findings also show that this must be done very carefully because, in fact, sometimes with low performers, describing more about how the AI works can actually have the negative effect in adjusting their mental models to be even more incorrect. Next, we're going to talk about how humans' cognitive biases affect their decision-making process. We know humans are not perfect systems. They have a number of biases that can affect their decision making. For example, confirmation bias is one of the most well known. If you believe something to be true, you look for more evidence to support it. But there are other kinds of cognitive biases that humans have. For example, anchoring bias. What you see first, you're more biased towards. We chose to study this, in particular how to try to mitigate some of these cognitive biases. We studied anchoring bias in particular. The way we did that is we tried to see if giving the humans more resources, especially more time, could then mitigate anchoring bias. If you think about it, it's about adjusting away from the AI prediction when the AI prediction is likely to be wrong. Our study showed that we were able to successfully mitigate anchoring bias using this time-based strategy, especially when the AI model confidence was low or incorrect. And it suggests that more research could be done to mitigate these kind of biases on the human side to improve their decision-making and human-AI collaboration. For the last topic in our section on human-AI communication, we're going to go over explainability. You can think about this using our conceptual model of collaboration by the example we gave earlier, visualization. That is one form of explainability. Remember there, the AI was trying to encode its internal state, present that on a channel that can affect what kinds of explainability options are available, and the human on the other side needs to decode that information. Our team is actively working in areas of research including visualization or visual explainability, as well as textual explainability. In particular, we've conducted studies where we test in human subject experiments different kinds of explanations. Even textual explanations can include different kinds of information within the textual explanation. For this particular study, we tested 4 different types. And we were able to show that some explanation types were more effective than others in supporting a human in choosing whether people in discerning whether there was a fair or unfair machine learning model. Of course, it depends on the type of fairness problem as well as individual characteristics. More generally, the team is now working on an XAI question bank that helps people reason about the explainability interfaces or explainability tools that could be incorporated into the interface to explain what's happening with the underlying AI. As well, there are a number of other resources for you to check out. Most of the major companies these days have explainability or design guidelines for designing AI systems. We encourage you to check those out. Finally, there are a number of open source toolkits in this space. Those include things like fact sheets for explaining how your AI was created, things like explainability or fairness, as well as an adversarial robustness toolkit for making sure your AI is secure. Finally, if these topics interest you, we encourage you to submit to the workshop we're holding at the Intelligent User Interfaces Conferences, IUI 2021. There'll be a workshop on transparency and explanations in smart systems. It's taking place in April, and your submissions are needed by December 23rd. Now let's go back to Werner so we can hear more about the next step. You've heard a lot about AI-human communication and collaboration, but what about co-creating something together?
Thank you, Casey. Now that Casey has covered some insights into communication aspects, including perception, mental models, cognitive bias, and explainability, and how those may impact how we design future human-AI collaboration systems, I would like to talk for a few minutes about another area we've made forays into: the human ability of creativity and how technological progress can lead us to human-AI co-creativity or co-creation. As you all know, a powerful new class of deep learning models, which are generative, has gained tremendous traction in the past few years. And while you're certainly very familiar with Ian Goodfellow's work on GANs and how they can be used to generate photorealistic images of fake people, these algorithms are increasingly used in industrial settings with very impressive results. For example, Airbus designed a new compartment divider for the A320 that used less material and increased maximum load capacity, reducing CO2 emissions. Airbnb developed a sketch-based user interface design tool that enables designers to test UX designs faster by translating sketches into code. And we at IBM Research, we demonstrated a path for the discovery of antimicrobial peptides, reducing drug discovery time from 2 to 4 years to 48 days, and with 10 times higher success rates. And the band Yard created their album Chain Tripping with generative AI, and it was nominated for a Grammy demonstrating inspirational aesthetic properties. And Autodesk has been using these tools and technologies for a while to design all sorts of objects. So we are at a point where we have reached what Douglas Eck called fluency in a recent keynote at one of our workshops. So we can build really good generative models. However, while we have fluency, there are still challenges. The production process is hard work, it's trial and error, and overall brittle. It involves manually creating, testing, iterating over multiple models, running bash scripts, combining results. The algorithms generally lack an understanding of the intent of the creative producers. Most of these are feed-forward algorithms, which makes it very hard to allow for control and steering the output in desired directions based on the human input. These algorithms often produce also way too many candidates, which makes it difficult to choose from. So there's information overload. And from a motivational perspective, we have to keep in mind that the people using these systems, they could feel a loss of ownership. The interesting question here for us is, how can we make these systems accessible to subject matter experts or domain experts? How do we design an effective co-creative user experience in which the role of the human changes towards specification, steering, goal setting, higher level creativity, and intuition, whereas the AI can provide inspiration, low-level creativity, and detail work, or generate variations at very high speed and quality. So let me give you an example to further illustrate this notion of human-AI collaboration in the context of co-creation and creativity. So this is ScanPaint, a painting tool we developed together with MIT. It's a pretty cool painting tool, and this tool, you don't paint by manipulating pixels, but rather with neurons by manipulating the latent space. In the UI, you can select objects such as trees, doors, bricks, etc., and just decide where you want to place those objects in the image. For example, I've added 2 trees to this cathedral in Sardinia on the right side in those 2 screenshots. If I added doors to the building, the model would exactly know the right proportion and merge them nicely into the existing image because the model has learned the properties of those objects. The interesting thing here to note is if I try to add a door to the sky, the model would not allow me to do that because it has learned that doors typically cannot be found in skies. So this is a good example in how this kind of interaction with a generative model is not only human-directed, but also has aspects of system direction and negotiation with the system. So I've left you a URL at the bottom so you can play with GANPaint yourself. So we've started experimenting with co-creation generative systems in business domains. For example, we've developed an interactive user experience that allows computational chemists to explore the latent space of a generative model for peptides with antimicrobial properties by interpolating between 2 known good peptides. So each peptide in the screenshot here on the right is represented as a sequence of characters, and we are showing various properties a chemist can examine, as well as the 3D structure, using their intuition and knowledge to further narrow down the selection. The peptides that came out of this work were actually synthesized and tested, and we found some working brand new AMPs here. Another domain we started looking into is applying generative models to the various tasks software engineers perform, such as coding, documentation, or testing. In this experiment, we explored the user experience of assisting software engineers with code translation from Java to Python. And the envisioned use case here is application modernization, a time-consuming and tedious activity. Here we used the neural machine translation model from Lachaud et al. From 2020 and conducted a design probe with 11 participants through semi-structured interviews to better understand their attitudes towards automated code generation, as well as get feedback on the user experiences we designed. For example, user experience B on the right-hand side shows the transcoder translation plus confidence highlighting, where the model was less confident in the translation. And user experience C underneath shows the transcoder translation, confidence, and alternate translations. Aside from detailed feedback on the user experience, there's two interesting findings I'd like to highlight here. So similar to auto AI, I talked about that earlier, trust came up as an issue. But in contrast to auto AI, however, our participants were not really interested in understanding how the model functions under the hood, but they argued that trust should be established in a similar fashion as if the AI were a team member by verifying the work through code reviews. And I left you a quote here on the screen, which you can read by yourself. Similar to a human peer who they would give feedback during code review, our participants raised the expectation that an AI system needs to learn from the feedback they provided, so it would become better at its job. Just to wrap up this section, this work here is really just scratching the surface in this exciting new domain, and that offers new opportunities for true human-AI collaboration and doing research in that space. I'd like to point you to two workshops on this topic. Lydia Chilton from Columbia, Mary Maher from UNC just invites IBM Research, and I are organizing the second workshop on human AI co-creation at IUI next year. There's still time to submit if you have an interesting paper or demo that fits into this space. Deadline is December 23rd. And the other workshop on machine learning for creativity and design takes place here at NeurIPS on December 11th and 12th. And I encourage you to participate if you get a chance. Our team has also 2 contributions there. So with that, now I'm handing it back to Casey to wrap it up.
We've clearly covered a lot of ground in this talk, and I'm going to review some of that with you before I turn it over to Werner to talk about what's beyond. So first, we advocated for a human-centered approach to AI development, which we use within our own team. Next, we talk about how we're using automation in order to aid in specialized problem solving for enterprise users. Trust and transparency are important in those applications and tools in order to aid adoption. Next, we talk about the trend towards human-AI collaboration, and we presented you with our conceptual model for how human-AI collaboration operates, and presented a number of research findings related to human sense-making around perception, and as well as mental models, as well as cognitive biases and how it affects decision-making, as well as explainability. All of those were built using theories learned from computer-mediated communication, as well as HCI, and we hope that those will continue to be brought in as we go beyond into things like creativity. There are a number of resources available that we hope you'll make use of in designing and building your own human AI systems.
Thank you, Casey, for this great summary. In conclusion, our research indicates that human workers desire more automation than they have today, but they do not want full automation. They prefer a partnership with an AI system. The studies we've shared with you today shed some light on the challenges in designing such a collaborative partnership. Moving beyond this partnership towards full automation, where systems are more directed by AI than by humans, does not necessarily mean evil AI systems are taking over the world and humans have no more control. We do see opportunities for human AI collaboration along the entire continuum of automation. They will just take a different form. And the more you are on the right side here of the spectrum, the more the term human in the loop will actually be an accurate description of that relationship, although unfortunately it is broadly used today when people talk about human-directed AI systems. So with that in mind, let me close with a quote from Tom Malone, which is very much in the spirit of our talk today. A lot of time today is spent on thinking about AI versus human as if it was a battle, but we should really think about how to design an effective partnership between human and AI systems. So thanks so much from both of us for attending our virtual talk here at the NeurIPS Expo. We hope you enjoyed it, and we're looking forward to connecting with you on Twitter. Stay healthy and be safe, and let us know if you have any questions. Thank you.
Okay, so that concludes the first day of our session on NeurIPS, Watchparty, and conferences. It was a wonderful time having all of you on board. Uh, we are really thankful to everyone who joined in via Zoom as well as on our Facebook. We realized that we have been delayed in our YouTube session, and we'll make sure to broadcast it live on time from the next. Anyway, thank you for all the panelists as well as the attendees who were careful enough to attend this first day, the introductory session of this seminar. So that's it, I guess. So I'll now like to request Debojyoti to end it.